Lesson 15, the electromagnetic force. Our objectives. First, you want to be able to define the electromagnetic force. This is something that we've actually already accomplished. In Lesson 13, you saw that the electromagnetic force is a force of attraction or repulsion which can arise from an electric or a magnetic field. You will also want to be able to describe the electromagnetic force between two charged particles, as well as to calculate the electromagnetic force between two charged particles. So let's get started. The electromagnetic force was described or discovered by Augustin de Coulomb. So these are things that Coulomb discovered about the electromagnetic force. The first is that like charges repel and opposite charges attract. Now, one of the interesting things about nature is that when it finds one thing that works, you will also find other similar things that are done the same way. So, in the last lesson, we took a look at gravity. So you will find a lot of things very similar about the electromagnetic force that you also learned about gravity. For example, like gravity, distance plays an important role. So with gravity, the closer the objects, the stronger the force. Same thing for the electromagnetic force. The closer the objects, the stronger the electromagnetic force. The further the objects get away from each other, the weaker the force. You'll notice this with magnets. The closer two magnets are to each other, the stronger the force is that they exert on each other. The further they're away from each other, the less noticeable the force. Also, with gravity, the larger the masses, the stronger gravity was. In other words, gravity depended on the sizes of the masses. With the electromagnetic force, instead of the mass, we work with charge. So the larger the charge, the stronger the force. The smaller the charge, the weaker the force. Something else that's interesting about the electromagnetic force in relation to gravity is the formula. And that is that the formula looks very similar to the formula for gravity. Notice that we have the force on the left-hand side, just like with gravity. Then we have a fraction on the right-hand side, with three things in the numerator and a distance squared in the denominator. Let's take a look at what all of these mean. F by now you know stands for force. In this case, it's a force of attraction or repulsion, and it will come out in newtons, as usual. The symbol of a lowercase q is used to represent charge. Since there are two charges, we need to be able to tell the difference between them. So we use subscripts, q1 for the first object, q2 for the second object. Then we divide by the distance of the object, which we're going to square, and that has to be in meters, just like gravity. Now that thing out front, just like gravity, is a constant. In this case, since it deals with the electromagnetic force, it's the electromagnetic constant. Since the electromagnetic force is so much stronger than gravity, the electromagnetic constant is a much bigger number. It's actually 9 times 10 to the 9th, or 9 billion. You will want to put this formula on your formula card underneath your formula for gravity. You can entitle this formula electromagnetic force, and you can also put down the electromagnetic constant so you don't have to memorize it. Here's an example. Two objects have electrical charge built up on them. Object A has a charge of positive 2 coulombs. Object B has a charge of minus 7 coulombs. They are 25 centimeters apart. What is the electromagnetic force between them, and is it attractive or repulsive? So we start as usual by identifying what we're looking for. We're looking for the electromagnetic force, denoted by an F. So we can put down our formula for the electromagnetic force. k times q1 times q2 divided by d squared. Now we can go through and list our information. K is a constant, so that's not going to change. It's not given in the problem either, but it has a value of 9 times 10 to the 9th, or 9 billion. Next we have our two charges. Object A has a charge of 2 coulombs. Object B has a charge of negative 7 coulombs. Next we need the distance, and it says they're 25 centimeters apart. Now remember, the distance has to be in meters, not centimeters. We have to be in our basic units. So really, we need to work with 0.25 meters. Now we can substitute our values in. You can put this in the calculator exactly as you see it, using the fraction bar. We get an answer of negative 2 times 10 to the 12th. Since this is a force, it comes out in newtons. Next, the question is it attractive or is it repulsive? This goes along with our third objective. In order to determine this, we could either look at the sign of each charge individually. So charge A is positive, charge B is negative. If one is positive and one is negative, they're opposites, and opposites attract. So the forces would be attractive. Another way of doing this is by looking at the sign in front of your final answer. In this case, it's negative. The only way to get a negative answer out is if one charge is positive and the other is negative. So a negative sign indicates that the force is attractive. If both charges had been positive, or if both had been negative, then the answer would have been positive. A positive sign would indicate repulsion. So in this case, our final answer, negative 2 times 10 to the 12th newtons, is attractive.